This is Digiduit. It's December 1st, 2018, and this video is titled The Hum, Creating Such a Buzz. Can this be anthropogenically initiated? I'd really like to say plausible, but not likely. But right now all I could say is plausible. Now, what I really want to do is talk about Mr. MDB's video he did back in May of 2018, and also I did a video on that same afternoon showing it was a worldwide event. And then I'd like to talk about the worldwide mystery event just happened. This is Secure Team 10's video there. But what I'm going to do is I'm going to start out in a little bit different place for you, okay? And there's Mr. MDB's video showing that most of these occurrences are about 10 kilometers. Well, there's a lot of occurrences at the depth of 10 kilometers. It's 6.2 miles for 32,808 feet 5 inches. So anytime we see 33,000 in my report here or presentation, just know it's about 10 kilometers deep. Okay, and here's some screenshots from his video. I'll give you his link on that one. And then now's a good time to introduce you to the what they call the Borehole discontinuity. It's named for Andrija Mohorovic, a Croatian geologist. It is specifically the boundary surface between the Earth's crust and the mantle, lying at a depth of about 6 to 7 miles, 10 to 12 kilometers under the ocean bed, and about 24 to 30 miles under the continents. Okay. Alright, let's see, I'm going to take you down here. Okay, this is where I'm going to start us out at. Scientists detect evidence of oceans worth of water in Earth's mantle. Now, I started out with an image here. I want to just kind of highlight what we're talking about. Now, this blue line represents what they call the transition zone. Alright, that's the transition between the lower mantle and the upper mantle. And this blue line, the transition zone itself, is predominantly dictated by the heat from the core of the Earth. Dictates where that's at. So I imagine it's at about the same depth all the way around the globe. But in the following excerpts of text, I'm going to be talking about the crust, which is right where the black background meets the horizon. You can't even see it here. It's not even depicted. And so the upper mantle is supposed to be, what they're saying, is harder, more dense rock than the crust. So let's just go on. That happens to be a schematic cross-section of the Earth's interior, highlighting the transition zone. Okay. And researchers have found evidence of a potential ocean's worth of water deep beneath the United States. Although not present in its familiar form, the building blocks of water are bound up in rock located deep in the Earth's mantle, and in quantities large enough to represent the largest water reservoir on the planet, according to research. So they might as well say, everything else in this article is basically a guess, okay? They're hypothesizing or whatever. It's not in its present form. So why they're calling it water, it's not water. There's hydrogen down it, there's hydrogen. There's oxygen, there's oxygen. If it's together in a form, then it might be water. But it's not. It's the building blocks of water. So they misrepresented this article. But I'm going to read some more of their stuff. The study combined Schmant's analysis of seismic data from the U.S. array, a network of over 2,000 seismometers across the U.S., with Jacobson's laboratory experiments, in which he examined the behavior of mantle rock under conditions designed to simulate the high pressures and temperatures present at 400 miles below the Earth's surface. Now here's an image of those particular arrays that they're talking about. Now, this below the image says the schematic representation of seismometers placed in the USA array between 2004 and 2014 and used by the study. Okay, so apparently the way I'm interpreting it is all these were installed between 2004 and 2014. I may be wrong there. Okay. The U.S. array is part of EarthScope, a program sponsored by the National Science Foundation. I remember that. You're going to hear them a lot. Jacobson's experiments were conducted at two Department of Energy user facilities, the Advanced Photon Source of Argonne National Laboratory and the National Synchrotron Light Source at Brookhaven National Laboratory. Taken as a whole, their findings produce strong evidence that melting may occur at about 400 miles deep in the Earth, with H2O, calling it water again, stored in the mantle rocks, such as those containing the mineral ringwoodite, which is likely to be a dominant mineral at those depths. Likely there's another one. See, this is just guesswork on their part. They should have just held off on this article. Excuse me. Schmandt explains that he made the discovery after carrying out seismic imaging of the boundary between the transition zone and the lower mantle. He found evidence that in areas where sharp transitions, like melt are present, some earthquake energy had converted from a compressional or longitudinal wave to a shear or an S wave. The phase of the converted S waves in areas where the mantle is flowing down and out of the transition zone indicated a significantly lower velocity than surrounding mantle. The discovery suggests that water from the Earth's surface can be driven to such great depths by plate tectonics, eventually resulting in the partial melting of the rocks found deep in the mantle. I'm going to read a little bit about ringwoodite. Schmandt and Jacobson's findings build on a discovery reported in March in the Journal of Nature, in which scientists discovered a piece of the blue mineral ringwoodite inside a diamond brought up from a depth of 400 miles by a volcano in Brazil. Okay, I got it. The tiny piece of ringwoodite, the only sample we have from within the Earth, contained a surprising amount of water, bound in solid form. Ice? No, I'm not getting it. Okay, not only was this the first terrestrial ringwoodite ever seen, all other natural ringwoodite examples came from shocked meteorites. But the tiny inclusion of ringwoodite is also full of H2O, there's that liquid water again, to about 1.5% of total weight. That must be different than just weight. They wouldn't have put total weight down there. They just said weight. Says Jacobson. This is about the maximum amount of water that we are able to put into ringwoodite in laboratory experiments. Although this discovery provided direct evidence of water in a deep mantle about 700 kilometers deep, Diamond sampled only one point of the mantle. Jacobson explains that the paper expands the search to question how widespread hydration might be throughout the entire transition zone. This is important because the presence of H2O in the large volumes of rock found at depths of between 410 and 660 kilometers would significantly alter our understanding of the composition of the Earth. It would double or triple the known amount of H2O in the bulk Earth, just to 1 to 2% H2O by the weight in the transition zone. Wait a minute, I'll do that over. It would double or triple the known amount of H2O in the bulk Earth. Just 1 to 2% of H2O by weight in the transition zone would be equivalent to 2 to 3 times the amount of H2O in the ocean, as Jacobson. There's their laboratory produced ringwoodite. Okay. Crystals of laboratory-grown hydrous ringwoodite, high-pressure polymorphic olivine. I'm going to go on a little bit lower here. So now I'm going to change pages a little bit. And here's what I think. Because they don't want to be accountable, fiscally or morally, they initiate, exacerbate, or duplicate naturally occurring disasters or calamities. Now, in Russia, main goal to reach 49,000 feet or 14.935 kilometers. There were a number of boreholes drilled that branched from one main borehole, but the deepest one was SG3. Actual depth reached by SG3, 40,230 feet or 12.262 kilometers. Now this is a video. I'm going to go ahead and, let's see if I got that pulled up. Okay, yeah, I'm going to show you this video here, okay? Usually I don't
Hey
do
friends,
this, but,
welcome to the Fact Land. Please
saying.
press subscribe icon and never miss our latest videos. Kola Superdeep Borehole. Deepest man-made hole on Earth. Many attempts to...
Okay, first I need to do this. I need to show you something. Saw that there. Saw that there. Alright. Now, actually, That's the borehole, okay? Don't think that's not it, okay? I don't know why they did that for us, but let me get back to the video. I'll show you some more. I'll give you a link.
Many attempts to drill through to the bottom of Earth's crust have been made since the 1950s, but so far no one managed to reach the final goal. Most of the stuff that scientists knew about the structure of the Earth back in the 1950s. The American project was called Project Mohole. They began drilling their hole on the Pacific coast of Mexico in 1961, but soon, after the initial drilling, they abandoned the project due to lack of funding. The Russian team was more fortunate in their efforts. They started drilling at a location on the Kola Peninsula on May 24, 1970. This scientific endeavor was called the Kola Superdeep Borehole, and from 1970 to 1994 they managed to penetrate one-third of the way through the Baltic continental crust and actually make the deepest hole in the world, which, in true depth terms, still holds the record today. When they started drilling, the main goal of the project was reaching down to 49,000 feet. There were a number of boreholes drilled that branched from one central hole. The deepest branch, called SG3, reached its final depth of 40,230 feet in 1989. The plan was to continue drilling and reach 44,300 feet by the end of 1990, and after that go down to 49,000 feet by 1993. But unexpected conditions and high temperatures on this depth stopped the operation in 1992. The expected temperature at the depth of 7.5 miles was 212 degrees Fahrenheit, and they measured 356 degrees Fahrenheit. According to this measurement, it was predicted that getting down to the planned depth of more than 9 miles would mean reaching a temperature of 570 degrees Fahrenheit, and it would be impossible for the drill bit to work in these conditions. The Kola Superdeep Borehole gave the world of science some major discoveries. Because of it, we now know more about our planet's structure. One of the most intriguing discoveries was the presence of microscopic plankton fossils 4 miles beneath the surface. The fossils found at these unexpected.
Okay, I have to stop that. They said micro fossils, and they're showing a picture of a crayfish and a fish, trace fossils of those. Alright. Now, this is why it takes me long to do research, because I get sidetracked. And I'm going to take you over there with me and be sidetracked. Now, the oldest crayfish lived in warm world, according to a press, and lived in a warm world. See, they left out a word and they screwed me up. Oldest crayfish lived in a warm world, according to a press release from Emory University, 5th of February 2008. A group of American and Australian researchers have found fossil crayfish and fossil burrows in Mesozoic rocks dated 115 million years old. Okay, 115 million. That's what I wanted to get to. Okay. It says, that came from the creation factor file. I'll give you that information too. In case we thought it might be a baby lobster or something in there. Mexico finds the world's oldest lobster fossil. Mexican scientists say they have identified the world's oldest lobster fossil, a creature that was alive when Africa was only just breaking apart from the Americas some 120 million years ago. Okay, so lobsters and crayfish, about 120, 125 million years ago, something like that. Okay, I'm going to give you that came from Reuters. Now, what did the Earth look like back then? Well, according to this image, I'll give you this link to here. It was somewhat like this. Not one continent, but not fully broken apart yet. I'm going to be cutting this video short. 511 million years ago was the first marine plankton. Okay, here we go. Alright, sorry about this. This is back about the Kola Superdeep Borehole. Okay, this is where the Kola Borehole is, right up here northeast of Finland there. Alright, and when I come back on the next video, I'm going to start out with Project Mohole. I'm going to talk about that. But I'm going to conclude this video right now. I just didn't know how fast I can get through it. So I'll make a part 2 to this, and we'll call it Project Mohole. Alright, sorry about this, and Digiduit.